In this video, we will talk about electric field, which is one of the main topic of electricity and magnetism, and is the initial topic. So we are starting with the electric field. So you must be knowing what is Coulomb's law when there are two charges which are placed at a distance r to each other, they experience a force. So in this, that has given the idea of an electric field. So electric field acting between the two charged bodies without touching each other. Those Coulomb's force exist even when the charges do not touch each other. So that has given rise to the concept of an electric field. Means if the two charges are interacting to each other and are exerting force on each other, then there must be something in between. So that has given the idea of an electric field. So we say that an electric field is said to exist if a force is exerted on a stationary charge placed near to it. So this is experiencing an electric field. So this is experience an electric field. Quantitatively, we describe electric field at a point as a force experienced by a unit positive charge. If there is a unit positive charge at that point without disturbing the source charge. If this is the source charge, I will take this as a source charge. So this is a source charge and this is a test charge. So if I am putting a test charge without disturbing the source charge, we see that there is an electric field which is existing because of the charge q onto the test charge. So the electric field is defined as the force experienced by a unit charge placed at that point. So we write E is equal to F upon Q naught. If I make Q naught as a unit positive charge, E is equal to F, and this is what we have exactly told. Electric field at a point is defined as a force exerted by a unit positive charge. So we can write by this formula F is equal to Q naught into E. You must remember this, which is very important. So the unit of electric field is newtons per coulomb. You must remember these two things. Electric field acts in the direction of the force, in the direction of the net force. Net force because of all the charges which are placed, because of the because of the different charges at a particular point, or the force acts in the direction of electric field. So both are same. So the force will always act in the direction of the electric field, or the electric field acts in the direction of the force. Now electric field due to a point charge, you know the Coulomb's law is 1 upon 4 pi epsilon naught q naught upon r square. If there are two charges plus q and plus q naught which are placed at a distance r, the direction of force, that will be a repulsive force. I have shown the force F which is acting because of this. So F upon q naught means F upon q naught means the electric field at this point. Electric field at this point, which I have ticked by red. So F upon Q naught is given by 1 upon 4 pi epsilon naught Q by R square. So this is the formula. If there is a point charge Q, so at, and we have to find out the electric field at a distance R from it, so it will be given by 1 upon 4 pi epsilon naught Q by R square. You can understand, because it is experiencing a force, the force per unit charge is given by 1 upon 4 pi epsilon naught Q by R square. So this is defined as the electric field. Now, if there are not one charges, which I was telling, if there are so many charges, now in this case I have taken two charges. There are two charges Q1 and Q2, and because of this, at a point P, if I have to find out the electric field, so I have drawn E1, that is the electric field, because of the charge Q1 with a direction, and because of the charge Q2 with a direction. Because those two forces will act in the direction, in the line joining both the forces. So E1 is the electric field direction, E2 is the electric field with its direction. So the net electric field is nothing but vector sum of both the electric fields E1 and E2, which we have can calculate with the help of the parallelogram. So net electric field is nothing but the vector sum of the electric field because of the different charges at a point. Similarly, the force acting at a point P will also be the vector sum of all the vector sum of the forces because of the different charges in the vicinity of in the vicinity of that point. Okay. So this is for the discrete charges. Now the charges can have a continuous distribution also. So I am just covering a small example of a continuous charge distribution also. So here the problem is electric field due to a long thin wire of linear charge density. It's a continuous charge distribution. The charge is continuously distributed. So charge per unit length we defined as lambda. Okay. Therefore the electric field, so the total charge dq, if I take a small element dq, which I can treat it as a point charge. So this dq will be given by lambda times of dx. It is given by lambda times of dx, and at a distance r at a point P, you can see that this is the line. Along this line dE, so electric field will act dE. The direction is shown here because it will act away because the wire is positively charged. So dE will act away. So to find out the net electric field, I have divided it into two components. One is the vertical component. Can see with green I have written dE cos theta, which is nothing but dEy, which is acting in the y direction, and dEx, which is nothing but dE sin theta, acting in the x direction. So if there is a total length L, you can define lambda is equal to Q upon L. So just exactly opposite to that, on the negative x-axis, there is another element dx which is similar to that, which I have done it with a yellow color. You can see because of this dE is acting in the line joining between P and dx. Okay, and it is away from the wire. Similarly, I have divided it, I have break up into the two components dex and dey. I have broken it into the two components dey and dex. As you can see here, dex because of the blue element and because of the yellow element, you can see dex, they are cancelling out each other, whereas the component green component, whereas the vertical component, because of the blue element and because of the yellow element, they are adding to each other. So the net electric field becomes dEy in the y direction is nothing but given by dEy is equal to 2dE cos theta. So now I can find out for the discrete, because dx is a discrete charge. So I am treating it as a discrete charge because it's a small charge. So I am applying the formula of the electric field which we have derived here. E is equal to 1 upon 4 pi epsilon naught q by r square. So it is 1 upon 4 pi epsilon naught dq is a small charge by r square. So this small charge dq is lambda dx, and I have substituted the value, and then I have taken the summation of all discrete charges. The summation of all discrete charges is done by the integration. It is 0 to L by 2. Why I have taken 0 to L by 2? Because dx component from minus L by 2 to 0 is already taken into account. That's why I have used 2 dE cos theta. So 0 to L by 2 is taken, and when I am solving this integral, if you are aware of how the integrals are solved, we have substituted the values and obtained E is equal to lambda upon 2 pi epsilon naught into y. So it is the electric field because of the wire which has a charge density lambda at a distance at a distance y away from it. So this is how we can calculate the same method. We can find out for all the other continuous charges of the different shapes. We can find out the elemental electric field and then do the summation to find out the net electric field, which we continue to cover in our other videos when we go more elaborate into this chapter. Or you can join our WhatsApp, you can join our app and then you can get the solution of all the problems that you want. So we will continue to discuss about electric potential and the relation between electric potential and electric field in our next video, which is very important for us to proceed further with the capacitance and then further topics into electricity. Hope you would have understood what is electricity. We will cover electric potential in the next video. Thank you.